Okay, these are moles to mass conversion notes. Okay, when converting from moles of one substance to mass of another, you will still need to start with a mole to mole conversion. Okay, so this is with the picket fence and the mole ratio. Then multiply that answer by the molar mass. Okay, now there's three ways to do it. You can do it in two steps, where you have one step is the mole to mole conversion, and then the second step is just a straight multiplication. Or you can do a double picket fence, or you can do a combination of both. I'm just going to show you the two steps right now. If you want to know how to do the double picket fence or the combination of it, just ask me and I will show you how. So we're just going to do it the simple way, the easy way. Okay, so either way, we start out with our picket fence here. So moles of given go in here. Now this is our mole ratio. So that means it comes from the equation. So whatever substance we're given goes here. So this is the mole from equation of the given substance. So whatever one we're given. And then this is the moles, I should say moles, yeah, from the equation of, I'm going to call it the wanted substance, of the substance that we want, of substance looking for. That sounds better. Okay, so this is your mole ratio, and this is how you do it. And this will give you moles, or the calculated moles of substance you're looking for. Okay, now you're going to take that and you're going to multiply by the molar mass of that substance, and that's going to give you mass in grams of the substance you're looking for. Okay, okay, so that's good enough for now. So let's try an example. So before I go any further though, since we're dealing with molar mass, sometimes it's easier just to calculate the molar mass of all the substances in the equation, and then you don't have to worry about calculating it afterwards. So let's do that. So iron, we know, is 55.85 grams. O2 is 32 grams. And guys, the molar mass has nothing to do with numbers. The numbers in front are the moles. They're not the grams. So you're not going to take 55.85 and multiply it by 4 for the molar mass of iron. We're talking about the molar mass of 1 mole, just 1 mole here. So it's just the substance itself. And that does not look like a really good 2. So I'm going to erase that and try that again. So, whoops, here, let's erase the whole G also. We'll put that back on there. So this is 32 grams. And then this is 159.7 grams. So for Fe, it's just Fe on the periodic table. So please, please do not multiply your molar masses by the number in front. It's not the molar mass of 2 Fe's. I don't care about the numbers. I want the molar mass of the substance and the substance alone. Okay. So now we're going to start out with 12.8 moles of the iron. Okay. Now we are looking for iron. So I'm going to go ahead and circle it. That's my favorite way of doing this. Iron and iron 3 oxide. So those are the two things we're going to deal with. So our mole ratio is the 4Fe to the 2 Fe2O3. So I have Fe on top. I have to put the Fe on the bottom. So moles of Fe, and then 2 moles of Fe2O3. Okay. Now when I do that, I take the 12, and I'm not going to write the middle step down here. I'm just going to do it on my calculator, but I'll explain what I'm doing. I'm going to take 12.8, and I'm going to multiply it by 2. I'm going to hit the equal button, and then I'm going to hit divide by 4. So I can just do it in one step. So we have 6 moles of Fe2O3. Now, when you're showing your work, you've got to show all of this. And your answer has to have, remember, it has to have a number, a unit, and a substance. Now, we're going to multiply it by the molar mass, which actually I wrote that wrong up there. That should be grams per mole, because you do have to put down grams per mole. So I'm going to multiply it by 159.7 grams per mole. And when I do that, so times 159.7, I get 1022 grams of Fe2O3. And that's because my moles both go bye-bye. Okay? And that's all there is to it. Okay, so let's try another example. So for this example, we're looking at how many grams of oxygen is needed to produce 15.9 moles of iron 3 oxide. So once again, I'm going to put my molar masses at the top. Remember, they're the molar masses of just, so that's a 159 grams per mole. Okay, and those are the molar masses of one of them, not a whole bunch of them. Okay, so for this one, I'll use red this time. So I'm looking for oxygen. And I'm given iron 2 oxide. So 15.9 moles of Fe2O3. So my mole ratio is going to be 2 to 3. 2 moles of Fe2O3 to 3 moles of O2 on top. This gives me 15.9 times 3 divided by 2. And I get 23.85 moles of O2. Now I'm going to take that moles and multiply it by 32 grams per mole times 32, and I get 763 grams of O2. And that's pretty much it. So hopefully you guys can do the practice problems. There's a bunch of practice problems that practice this. The main thing is, I think, is getting this mole ratio correct. That's probably the hardest part. And then also making sure you have the correct molar mass. You also have to make sure, please, please, please make sure you have all of your equations balanced. I balanced them for you here. So I gave you the balanced chemical equation. Any quiz we have and any test we have and any practice problems we have, you're going to have to balance the chemical equation. Okay? If you have any problems, just ask me in class. Bye.